I'm going to answer a Leaving Cert Maths paper 1 question from 2019. It's question 5 on complex numbers. You're told that 3 plus 2i is a root of that quadratic equation. You're told that p and q are also real numbers. As the coefficients of x, or even z in this case, are all real numbers, then by the conjugate roots theorem, the other root, if one root is 3 plus 2i, the other root is 3 minus 2i, its conjugate. Okay, as it's a quadratic, something else that's important, the sum of the roots is equal to minus b over a, where the coefficient of z squared is a, coefficient of z is b, and a constant is c. So the sum of the roots is minus b over a. In this case, it's minus p over 1, which is minus p. So therefore, 3 plus 2i plus 3 minus 2i is equal to minus p. Okay, we add those together. 6 equals minus p. Therefore, p is equal to minus 6. Also, what we know is that the product of the roots is going to be c over a. So 3 plus 2i times 3 minus 2i is equal to q over 1, which is q. The product of those conjugate roots is just going to be 3 squared plus 2 squared. If I multiply that out, that's going to be 9 plus 4. As the imaginary terms will just cancel out, 9 plus 4 equals q. So therefore, q is equal to 13. In the next question then, you're told that v is 2 minus 2 root 3i. Write v in polar form. Okay, so we've got two things with polar form. We've got or, which is modulus, and we've got theta, which is the argument. So, best thing to do when answering a question like this, just draw a quick sketch, okay, of the argand diagram of your complex number v. So the real part is 2, so that means it goes across 2 on the x-axis, and the imaginary part is minus 2 root 3, which is, let's say that's around here. So let's just say that this is v. Okay, so that's my complex number v. Now the argument is going to be the angle that it makes with the positive sense of the x-axis. And the modulus is the distance between it and the origin. Now, we can work out or, if it's that green line there, because using Pythagoras, or squared is equal to, that's 2, and that's just a distance of 2 root 3. Or squared is equal to 2 squared plus 2 root 3 squared. So, or is equal to 4 plus 12. That's the square root of 4 plus 12. So that gives me an answer of or is equal to root 16. Okay, so I've worked out or. Now I need to know the argument. Again, we can just use trigonometry. Let's say we're looking for that angle, call that angle alpha. Well, the tan is equal to SOHCAHTOA. Tan is equal to the opposite over the adjacent. So it's 2 root 3 over 2, which is root 3. So therefore, alpha, might as well write alpha properly, alpha is equal to inverse tan root 3. So you look up your tables, inverse tan of root 3, and it's looking for it in radian form. So inverse tan of root 3 is, so inverse tan of root 3 is just going to be, here's tan, and I go across to root 3 is 60 degrees, okay, or pi over 3. Okay, so that angle there, alpha, is just pi over 3, because the tan of pi over 3 is root 3. So alpha is equal to pi over 3. Well, I know that the entire circle there is equal to 360 or 2 pi. So therefore, theta is equal to 2 pi minus pi over 3, which is 5 pi over 3. So I need to write that complex number in polar form. Well, or is just 4. And it's going to be cos 5 pi over 3 plus I sine 5 pi over 3. Okay, next question. Use that answer to find two possible values of w where w squared is equal to v. So therefore, w is equal to v to the power of a half. So v to the power of a half is equal to the power of a half. General form would be 4 cos 5 pi over 3 plus 2n pi plus I sine 5 pi over 3 plus 2n pi. So we want that whole thing to the power of a half. Well, that's going to be 2 outside of cos 5 pi over 6 plus n pi plus I sine 5 pi over 6 plus n pi. Now, let n equal to 0. We have 2 outside of cos 5 pi over 6 plus I sine 5 pi over 6. So what we could do is look up, you could use a calculator or look up the tables here for this. So we're on cos of 5 pi over 6, which is just less than 6 pi over 6. Okay, so we're in this quadrant here. This is pi there. We're in quadrant 2. Now cos is negative in quadrant 2. So the answer to cos 5 pi over 6 is looking up cos pi over 6, which is root 3 over 2, but realizing that the cos of 5 pi over 6 is actually in the second quadrant, and cos is negative in the second quadrant, so that's going to be minus root 3 over 2. So we've got 2 times minus root 3 over 2 plus sine of 5 pi over 6, which is here. Now sine, and if we look up pi over 6, which is the reference angle, we get a half. Because we're in the second quadrant, sine is positive in the second quadrant, so CAST, sine is positive in the second quadrant, so it's plus a half I. So that answer actually becomes minus root 3 plus I. Now if we let n equal to 1, we get 2 outside of cos 5 pi over 6 plus 1 pi, which is 6 pi over 6. So it's going to be 11 pi over 6 plus I sine 11 pi over 6. You can look this up in the calculator, but if you want to just use your tables, 11 pi over 6 is here, just less than 2 pi, which is a full revolution. Our reference angle becomes pi over 6 again. We know that cos of pi over 6 is root 3 over 2. But I'm in the fourth quadrant now, 1, 2, 3, 4, and cos is positive now in the fourth quadrant, so that just becomes root 3 over 2. So it's 2 times root 3 over 2, and sine is negative in the fourth quadrant, so it's minus half I. Again, you can just put it into your calculator, and twice that gives you root 3 minus I. So our answers become minus root 3 plus I, or else root 3 minus I for that question there.